Good day everyone, you are welcome back to mathematics class. Today we are going to be looking at the topics sequences and series. Now let's begin. What is a sequence? A sequence is an arrangement of numbers in a definite or well-defined order, and each number in a sequence is called a term. So now let's take a look at some examples. Okay, example of sequence. Now when we have 2, 4, 6, 8, 10, and so on. Now you can see that these numbers, they follow a particular pattern. Okay, so that's why we said a sequence is an arrangement of numbers in a definite or well-defined order. When you add 2 to the first term, you are going to get the second term. When you add 2 to the second term, you are going to get the next term. Okay, so here I said that each number in a sequence is called a term. That is, this 2 now is the first term. This second number 4 is the second term, third term, fourth term, fifth, and so on and so forth. Is that okay? So another example is when you have 3, 6, 12, 24, and so on and so forth. You can see this one to it also follow a particular pattern. Okay, so when you are multiplying 2 by each term, you are going to be getting the next term. For example, 2 times 3, that will give you 6. 6 times 2, that is 12. 12 times 2 is 24. To get the next one, you are going to say 24 times 2. It will give you the next term. Okay, and let's look at one more example. 5, 10, 15, 20, and so on and so forth. So this also is an example of a sequence because it follows a particular order, a well-defined order. Okay, so what is that order? The rule is just adding 5 to each term. So this first term plus 5, it will give us 10. Then this second term, which is 10 plus 5, 15, 15 plus 5, 20, 20 plus 5, 25, and so on and so forth. So that is what a sequence is all about. All right, so types of sequence. Number 1, we have arithmetic sequence, or you call it arithmetic progression. Okay, so and this is a sequence in which the difference between consecutive terms is constant. Just like in the previous examples I gave, you can see that the differences between those numbers are constant. Well, take for another example here. When you have 2, 5, 8, 11, 4. So what was the difference between this number? All right, so let's find it common. The common difference is equal to, how do you find the common difference? You just take second term, which is 5, minus the first term, which is 2. So 5 minus 2, that will give us 3. Abi? Alright, so if you take again the third term, which is 8, 8 minus the second term, which is 5. 8 minus 5, it will still give us what? 3. Alright, so take the fourth term, which is 11 minus 8. So 11 minus 8 will give us what? 3. So you will note that the common difference denoted with letter D is equal to 3. So the differences between this this set of number is equal, is constant. So, and that makes this example I gave here to be an example of arithmetic sequence or arithmetic progression. Is that understood? Okay, so the second type of sequence is geometric sequence, or you call it geometric progression. So, and this is a sequence in which each term is obtained by multiplying the previous term by a constant number. Okay, so here let's take for example we have 3 comma 6 comma 12 and 24. Okay, so don't forget, under this arithmetic sequence what we found was common difference. But when we are dealing with a geometric progression, what we are going to be looking at is common ratio. Is that okay? Common ratio. And it's denoted with letter R. So what is the common ratio here? And let me also add here that the way we found common difference here is taking the a term and subtracting the previous term from it will give us the common difference like we did in arithmetic sequence. But in geometric sequence, we are going to be taking the a term and then divide it with the previous term. For example, second term, which is 6 divided by 3. 6 divided by 3 will give us 2. All right. Then take the next one, 2, which is 12. 12 divided by 6, that will also give us 2. Then take the next one, 2, which is 24 divided by 12. That will also give us what? 2. You can see that everything is constant. Okay, their common ratio is what? Is constant. All right, so if you now multiply each term by 2, it will be giving you the next term. Take for example, the first term is 3. 3 times 2 will give you 6. Then 6 times 2 will give you 12, the next term. Then 12 times 2 will give you 24. That's why we said that geometric progression is a sequence in which each term is obtained by multiplying the previous term by a constant number. Understood? So in this case of the example I gave you, the constant number is 2. It varies from one question to the other. Is that understood? All right, so let me quickly speak on the series as well. So a series is the sum of the terms of a sequence. Now we have dealt a bit at the sequence. Now when you are given a sequence, for example, okay, so a sequence like I have explained before, 2, 4, 6, 8, 10, and so on. So this is an example of a sequence. Now what series is showing us is that when you add all the terms in a sequence together, that is what we call series. That is 2 plus 4 plus 6 plus 8 plus 10. All right, so this is what we call series. So a series is the sum of the terms of a sequence, as simple as you have seen it on the screen. Now let's take a look at some worked examples. The first question says, state whether the sequence below is arithmetic or geometric. All right, solution. So we have 4, 8, 12, 16, 20. Don't forget, I have explained what arithmetic progression and geometric progression is, and that is what you need to answer this question. Now, for us to know maybe this is arithmetic or geometric, so let's first of all see maybe it is an arithmetic progression. So I'm going to do that by finding the common difference of this particular sequence. Okay, so the differences, now let me write differences. Now then I will take the second term, which is 8 minus 4. That is how to find the differences. Okay, 8 minus 4 is equal to 4, right? Then the third term, which is 12 minus the second term, 8. 12 minus 8 is also 4. Then if you take 16 minus 12, that is also 4. And 20 minus 16 will also give us 4. You can see that the common differences are constant. Is that understood? So since this particular sequence is having common, or let me say constant differences, then we can just conclude and say it is an arithmetic progression. Okay, or arithmetic sequence. So let's just conclude and say since the difference is constant, okay, so it is an arithmetic sequence. Understood? So that's how to answer this type of question. So the next question says identify the rule of the sequence below. That is, what they are asking us is to find the pattern, the definite pattern that this sequence follow. Okay, solution. Now this one is just by mere observation you are going to get your answer. So what is the rule? If you look at the sequence given to us 5, 10, 20 and then 40, when you multiply each term by 2, you are going to get the next term. Take for example this first term, 5 times 2 is 10, then 10 times 2 is 20, 20 times 2 is 40, 40 times 2 will give us 80, and so on and so forth. So therefore the rule is that multiply each term by what? By 2. So multiply by 2, that is the rule. Now let's take a look at another question. The question says for the sequence below, find number 1 the next 3 terms, then 2 the rule which gives the terms. Solution. Alright, so the sequence is 1, 4, 9, 16, 25 and so on. So before I can find the next 3 terms, I have to understand the particular order this sequence follows. So I have 1, 4, 9. So if you observe very carefully, you will understand that these numbers given to us, they are just perfect squares. Square root of 1 is 1. Square root of 4 have a particular square root, okay, so it's a perfect square. 9 is also a perfect square. 16 is also a perfect square, and then 25 is also a perfect square. You will see that all these listed numbers are perfect square. Understood? So for me to now know the next 3 terms, let me write here Roman figure 1. The next 3 terms will be after 25. The next one is 36. Okay, 36. Then after 36, the next one will be 49. And then after 49, the next one will be 64. Okay, the simple logic is just write the numbers 1, 2, 3, 4, 5, 6, 7 and so on. Then 1 times 1 will give us 1. Then 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. Then 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8 is 64. Understood? So that is what they ask us to do. Now the second question says we should find the rule which gives the term. Already we have said that the rule is that it's a perfect square. Perfect square. Okay, so that's the rule. All these numbers you are seeing are perfect squares. Now that's the end of that question. Now another question says find the first, third and the 12th terms of the sequence whose nth term is 4n plus 3. Solution. So when you see this type of question, just make use of this algebraic expression given to you to find the first term, the third term and the 12th term. Now the first term, the first will be equal to, using this expression, we have 4n plus 3. So this n is the number of term and the number of term here is 1. So we have 4 times 1 plus 3. So 4 times 1 is 4 plus 3, and 4 plus 3 will give us 7. Okay, so we have third. The third term will be equal to 4n plus 3, and 4 times n this time around is 3, the third term, plus 3. Then 4 times 3 is 12 plus 3, and 12 plus 3 is 15. And then the 12th term will be equal to 4n plus 3, and n is 12, then plus 3. So 4 times 12 is 48 plus 3, and 48 plus 3 is 51. All right, so these are the value of the first, third, and the 12th term of a particular sequence whose nth term is 4n plus 3. All right, so let's continue. Now at this point, I want you also to take your time to solve these 4 questions. They are very simple. So pause this video now and solve them. After you might have solved them, then you can continue the video to see the solution at the other side. All right, so let's continue. Now the question says, determine whether the sequence below is arithmetic or geometric. Solution. So we have 4, 9, 14, 19, and 24. Now let's test for arithmetic first. So we are going to find the differences between the terms. Okay, so let's find the differences. Okay, so the second term, which is 9 minus 4. 9 minus 4 is 5. Okay, let's test again. Let's pick 14 minus 9. 14 minus 9 will also give us 5. Let's test again. 19 minus 14. Okay, so 19 minus 14 will also give us 5. Okay, so since we have a common difference, a constant difference, then we can just conclude and say this sequence is arithmetic sequence. Do you understand? Okay, so let's just say is an arithmetic sequence. All right, so let's take a look at another one. Determine whether the sequence below is arithmetic or geometric. Okay, solution. All right, so we have 2, 6, 18, and 54. Now let's test for arithmetic first. The common difference, the first one is 6 minus 2. 6 minus 2 will give us 4. Then the next one, 18 minus 6. So 18 minus 6 cannot give us 4. So the common difference is not constant this time around. So definitely it's not arithmetic, it's going to be geometric. But let's test for geometric before we can conclude. Okay, and in the case of geometric, we are going to find the common ratio instead of common difference. Okay, so the common ratio, and we take the second term, which is 6, divided by the first term, which is 2. So 6 divided by 2 will give us 3. So let's test again the third term, which is 18 divided by 6. 18 divided by 6 will also give us 3. And lastly, 54 divided by 18, and that will also give us 3. All right, so meaning that when you multiply each term with these 3, the common ratio, you are going to be getting the next term. Take for instance, 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. So since the ratio is constant, then this particular sequence now is what? Is a geometric sequence. Understood? All right, so let's continue. This question says, identify the rule of the sequence below and find the next 3 terms. All right, so solution. We have 2, 3, 5, 7, 11, 13, and so on and so forth. So the question says we should find the rule of the sequence below. Then we'll find the next three terms. Now let's study this sequence closely to see what particular order did this sequence follow. So we have 2 and 3. So 3 minus 2 is 1. So are they adding 1 1? No, it's not 1 1 they are adding. Okay, so if you observe carefully, you will notice that all these numbers written, they are their prime numbers. Okay, so 2 is a prime number. The next prime number after 2 is 3. The next prime number after 3 is 5. After 5 is 7. Then 11, 13. You can see. So the rule is, let me just write it here. The rule is that all these are what? Prime numbers. Okay, so this sequence just listed the prime numbers that we have. Okay, so that's the first question. The second question says find the next three terms. Now that we understood the definite order that this sequence follow is just prime numbers, then it is easy for us to find the next three terms. So the next three terms are going to be, let me write the next three terms will be equal to the next prime number after 13 is 17, then followed by 19 and 23. So these are the next three terms. So if they ask you to find more than the next three terms, then you continue writing the prime numbers as they follow each other. This is the end of the solution to this particular question. So let's continue. Find the first, third, and 12th terms of the sequence whose nth term is n squared plus 3. Solution. Alright, so here we are given this algebraic expression n squared plus 3. So and that's what we are going to use to find the first term, the third term, and the 12th term. So this n in this expression is where we are going to be putting the value of each term. Okay, so first term now, first term will be equal to n squared plus 3. Since it's first term, then the value of n here will be 1 squared plus 3. So 1 squared is 1 plus 3, and that will give us 4. Okay, so the first term is 4. Now the third term, the third will be n squared plus 3. So the value of n here is 3, then squared plus 3. 3 squared is 9 plus 3. And 9 plus 3 will give us 12. And then finally 12th term will be equal to n squared plus 3. So the value of n here will be 12, then 12 squared plus 3. So 12 squared is, that's 12 times 12, and that's 144 plus 3. Alright, so 144 plus 3 will give us 147. Alright, so and at this point, this is where we are going to be ending today's class. Alright, so see you in our next class. Bye.